Alright, silly people, here's the situation. We're going to be creating the Feigenbaum plot using matplotlib and Python, um, and also making use of NumPy to do so. Um, the idea is it's kind of like a classical um, plot that's representing chaos or deterministic chaos. And so, uh, just starting this out, of course, we're going to need matplotlib, so we need to import matplotlib.pylab as pt, and also numpy, like I said. Um, the equation that we have to do is it's an x prime is going to be equal to x times r times 1 minus x. So I'm going to do it x times equals r times 1 minus x, right? But then we have to figure out what goes around that. It says to start with a value of x equals 1/2 and iterate the logistic map 1,000 times for a given value of r, but then also iterate r from 1 to 4 in steps of 0.01. So we have to create a for loop for r in, it's going to be an a range. So it's going to be 1, 4 with steps of 0.01 in between the r's, right? But then also you need a for n in 1,000 so that it iterates the logistic map 1,000 times. And then you do your x times equals thing. And it says to create a scatter plot for all of these x values that we're going to get, right? And so I'm going to put the x equals 1/2 here. That's where the initial value has to go. The fastest way to make your code do this is to create lists inside of the R loop, and then plot it at the end of the R loop for each iteration of R. But then also I'm going to plot it so it plots the final point in a different color as like the rest of the points in the function, so that you can also see where each iteration of R ends up, and if it ends up being a limit cycle or not. So I'm going to create a list for every value of x, and we're going to create a list of values of r, but each element of this list is going to be the same value of r. It's just going to be a vertical line of a bunch of dots. So we're going to use the np.full function, which creates an array of a specific size. I'm just going to make it a 1D array with 1,000 elements, and all of them are going to have the value of r. And then as n iterates, we are going to append the x list with values of x, and then scatter it at the end. XLS versus RLS. That's not right. It needs to be R versus X. Yeah. And then for these guys, I actually want them to be green. And I'm going to manually make the marker size for each of the plot points 0.01, because there's going to be a lot of points. There's going to be 1,000 points per R and a lot of different values of R. So make them quite small. And then also just at the end, plot the value of R and the last value of X in red, let's say, and then make the marker size a little bit bigger, make it like 0.5. Put a comma here so it's grammatically correct. And then that should be good. Oh, we need to show it at the end. So make sure to write plt.show, just so it makes it only show it at the end and not every time it iterates through the list. Int object is not iterable. Oh, because this needs to be a range 1,000, my bad. I'm off my game today. But then, after a few seconds, Ooh, bam. Okay, there's the Feigenbaum plot. You can kind of see the red dots where the iterative map ends up being a fixed value, and then it has these limit cycles towards the middle here, and then these are all like completely chaotic motion towards the end. Um, the the problem has a few questions that comes with it. For what value of r, for a given value of r, what would a fixed point look like on the Feigenbaum plot? Well, it looks like everywhere from like 1 to like 3, where it starts being, it always ends at like the same value, uh, converges pretty quickly. And so those are all of those. Um, what a limit cycle would look like, it would cycle just between the two values, like here in between 3 and 3.5. This is a limit cycle. It's just cycling between these two values. This is a limit cycle, but also 1, 2, 3, 4. This value of r is cycling between like 4 values of x, and so on over here. This is a limit cycle as well. And now everything after that is what chaos looks like. Based on the plot, what value of r does the system move from orderly behavior to chaotic behavior? So we can try and zoom in on this by limiting the range. So it kind of looks like it's getting towards chaotic behavior around 3.6. So let's look at that, 3.6. And then, so it's catching the end of the limit cycle right here, of the last limit cycle, but we can try and increase the fidelity. It looks like it starts becoming really chaotic around 3.68. So let's try 3.67. Yeah, okay. The first data point there will capture the last of the limit cycle, and then everything afterwards becomes chaotic, and then there's a limit cycle in between. Chaos again, limit cycle, chaos. And I think it just stays chaos after that. So yeah, cool stuff there.